Okay, so let's start with today's class, which is about laws of motion. So it's a continuation of what we did yesterday. So yesterday we were talking about kinematics, where we were relating the position, displacement, velocity, and acceleration of particles through some equations. Now we will talk about forces. Okay. So before talking about forces, we have to talk about Newton's laws. So there are three laws of Newton's. The Newton's first law, it talks about inertia. So a body at rest will remain at rest, and a body at constant velocity will keep on moving with the constant velocity unless an external force is applied on that object. Okay. Okay, so this means that if there is a block of mass m which is moving with velocity v on a frictionless plane, then it will keep on going with that velocity. It will only stop if there is friction between the block and the surface. Okay. The second law of Newton talks about the numerical value of force. So it says that force is directly proportional to the acceleration, and the constant of proportionality is nothing but the mass of an object. Okay. So this second law also tells you an idea of what mass m of an object is. So mass is nothing but the constant of proportionality between the force and acceleration in the Newton's second law. So a heavier object will require a greater amount of force to be accelerated by the same amount than a lighter object. So that is why a truck consumes more power to travel at the same speed than what a motorcycle consumes, because the truck has a greater mass and therefore greater amount of force is required. Then the Newton's third law says that action is equal to the reaction, and both of them act in the opposite directions. So there are two things to remember here. First is that action and reaction, they are not acting on the same body. Action is reacting, action is acting by the first body on the second body, whereas reaction is being acted on the first body by the second body. Okay. So let's say this is body A, this is body B. If body B is being acted by a force FBA, this force is acting on B by body A. Now the reaction force will not act on the same body, the reaction force will act on the other body, and this will be FAB. So the third law says that these two forces, which are an action and a reaction pair, are equal and opposite. So let us take some examples. Let's say a block of mass m is lying on the ground. So this block will exert a normal force on the surface, and the surface will exert a normal force on the mass, which will be the same value but in the opposite direction. Okay. Then another example is the gravitational sun-earth system. The sun, the earth is orbiting the sun in an elliptical path. The earth is being attracted by the sun with a force of gravity, and the sun is also being attracted towards the earth with the same force of gravity, but in opposite direction. So then the next thing to discuss in this chapter is the forces of friction. So there are two types of friction. One is the static friction, which is the friction which acts between two bodies when they are not moving relative to the other. Okay. And the other type of force is kinetic friction, which acts when the two bodies are moving against each other with some velocity. Okay. Now, this static friction has a maximum value which is equal to mu of static friction times the normal force. Okay, now you have to be careful while learning about static friction is that this is not the static friction value, but this is the maximum value. So if you are applying a force which is less than this maximum value, then the static friction will not be equal to mu Sn. Okay. In that case, the static friction will just be equal to the same force. So if the maximum value of friction is, let's say, 100 newtons, but you are only applying a force of 50 newtons to the right, then the force of friction will not be 100 newtons. Okay. Because in that case, the block will go to the left. Okay. So let's say we apply a force of 100 newtons. In that case, the force of friction will be 100. Okay, now what will happen if you increase the applied force beyond 100? Let's say we make it 120. The block will start moving, but the frictional force will not increase because it has reached its maximum value. And now to calculate the acceleration, you will take the net force, which is 20, and divide it with the mass to get the acceleration. Then for kinetic friction, there is no maximum value because the block is already moving with some velocity v. So force of kinetic friction is always equal to mu k times the normal force. Okay. And then there is one more thing, that the coefficient of static friction is greater than the coefficient of kinetic friction. Why is that happening? So one theory says that frictional force acts because the two bodies in contact, they cling against each other by, for the irregularities on the surface of one object, they come together with the irregularities of the top surface. Okay. So in this example, these two irregularities, they merge with each other, and due to these merging there is no smooth movement, and that is how friction acts. Okay. Now when an object is at rest, these irregularities have clung on to each other very tightly. But when the bodies are moving against each other, these irregularities will not get time to cling along each other. So if they are at rest, then the irregularities are tight, so there is more friction. That is why the coefficient of static friction is a little bit greater than the coefficient of kinetic friction. Okay, so then the next kind of force that we study is the tension force. So in these types of problems, you have pulleys. One end of the pulley uh, is hanging with some mass m1. The other end of the pulley has some mass m2 attached to it, and you have to calculate the acceleration or the tension force in one of the strings. Okay. So in such problems, you draw the free body diagram of the individual masses. So for the mass m1, there will be a downward force m1g, which is the gravitational force. There will be an upward force, which will be the tension force in the left side pulley. Okay. Similarly, for the other mass m2, there will be a downward force which will be equal to m2g, and there will be an upward tension force which will be ft2. Okay. Now, if it is given in the problem that the pulley is massless and frictionless, okay, so listen to this carefully. Only if the pulley is massless and frictionless, we will say that this tension force will be equal to this tension force. If the pulley has mass and there is friction, then these two tensions will not be equal. But if these are frictionless, then we can simply say the two tension forces are equal. So we can remove the subscripts and make them equal. Now you will write the equation for the first pulley. Let's say this pulley is going down and this mass is going upwards. So the acceleration of the two masses will also be the same because they are connected by the same string. So the equation will be f of t minus m1g equals m1a. And for the second block, we will write m2g minus ft is equal to m2a. Now we have two variables, ft and acceleration, and we have two equations, so we can solve for both the forces and the acceleration. Okay. Then in some problems, you have a system of pulleys. So if you have a system of pulleys like this, then what will be the equations that you will write? All the pulleys are frictionless and massless. So first we will assume that the tension force in all the pulleys are the same because they are a single string. So we will say this force is T, this force is also T, this force is also T, and this force is also T. All the forces are same because they are connected by the same string. Now, for this mass m1, you can write m1g minus T is equal to m1a. And for the second mass, you can simply write T minus m2g is equal to m2a. So similarly, you can, whatever the system is, you can just label all the forces and write the equations accordingly. Okay, so then uh, we have the circular motion. What is the centripetal acceleration in a circular motion? So if a body is going along a circle, a horizontal circle, then the body will accelerate because the velocity is changing at every point. The body is not going in the single straight line at all the points, therefore its velocity will not be the same. The magnitude of the velocity is same, but the direction of velocity is changing, therefore there will be some acceleration. This is called the centripetal acceleration, and its direction is always along the center. So at all the points, the direction of the acceleration will be along the center of the circle. And the magnitude of this acceleration will be equal to v square over r, where r is the radius and v is the linear velocity at all points. Okay. So if you have a stone tied with a rope and attached to a string, and this string is going along a circle, what will be the tension in this string in terms of mass and the velocity? V square by r will be the acceleration, and therefore the force of tension in this case will be mv square. So here we will say the tension force is providing the centripetal force. Okay. Centripetal force is not a separate physical force. It is just the name of whatever force is acting along the center. Okay. So like normal force is a physical force, friction force is a physical force, tension force is a physical force, but centripetal force is not a physical force. It is the name given to any force which is acting towards the center. Okay. Okay. Then in the sun and the earth system, suppose the earth is going in a circular path around the sun. What is the force of gravity exerted by the sun? G, mass of sun, mass of earth upon r square. And this is also the centripetal force. So we can say this will be equal to mass of earth times v square upon r. So using this equation, we can calculate the velocity of the earth while going around the sun. Okay. So v square will turn out to be g mass of sun divided by r. Okay. And therefore the velocity of the earth around the sun will be given by square root of g ms upon r. Okay. Okay, now let us see what would happen if the circular path was vertical. Okay, so in a vertical circle, we will look at different points along the circle. Let me draw the circle correctly. Okay, so in a vertical circle, the difference is that the gravitational force is also acting. Okay? So if the gravitational force is also acting at all the points, we also have to consider the effect of gravity. So let's say there are four different points. A is the bottommost point, B is the rightmost point, C is the topmost point, and D is the leftmost point. Okay. Now, when the mass is at position A, what all forces will be acting? Okay. So this is the circular path, and a ring, a ball of mass M is going along this path. Okay. So it is doing rounds on the inside of this path. So one force will be the gravitational force at point A, and the other force will be the normal force, which will be upward. So in this case, what will be the centripetal force equal to? So centripetal force is the net force along the center. What is the net force along the center at point A? So at point A, F centripetal will be equal to Fn minus Fg, and this will be equal to mva square upon r. Okay, now let's come to point B. Let's come to point C first. So at point C, if the ball is like this, both the normal force and the gravitational force are acting downwards. So at point C, the centripetal force will be Fn plus Fg. So this will be equal to mvc square upon r. Okay, so sometimes they ask a question like, what should be the minimum velocity at A so that the ball is able to do the complete circle? The question is, what should be the minimum velocity at A if the ball is able to complete the full circle on the loop? So we have to find the velocity at A given that the ball also passes through the topmost position, right? So let's say the velocity at the topmost position is Vc. Okay. So we have two equations. One is Fn minus Fg at C is equal to mva square upon r. And the second equation is Fn plus Fg at the topmost point is equal to mvc square upon r. Can we also relate Va and Vc using conservation of energy? So can you use conservation of energy at point C and point A? Okay. What is the total energy at point A? Kinetic energy plus potential energy. Okay. So kinetic energy is half mva square. Potential energy is 0 if we assume the reference to be the level of point A. Okay. So this will be the total energy at point A. And will this be equal to total energy at point C? So what is the total energy at point C? Again, kinetic energy half mvc square plus the potential energy. mgh, where h is now equal to 2r. So plus 2 mgr. So the equation relating VA and VC becomes VA square is equal to VC square plus 2GR. The M and the 2 factor, they cancel out. Wait, is it the correct equation, or have I made some mistake? So here there should be 4GR. So now we have the equation connecting VA and VC. So let's come back to our question. The question was, what should be the minimum velocity at A so that the ball completes a full circle? Okay. For completing a full circle, the velocity at C must be minimum. Okay. That means VC should be minimum. Now VC will be minimum when Fn plus Fg will be minimum. टॉप पॉइंट पे वेलोसिटी जीरो इसलिए नहीं हो सकती बिकॉज अगर वेलोसिटी जीरो हो जाएगी एम वी स्क्वायर अपॉन आर जीरो हो जाएगा. एम वी स्क्वायर अपॉन आर जीरो हो जाएगा, इसका मतलब एफ एन प्लस एफ जी जीरो हो जाएगा. बट एफ एन प्लस एफ जी का भी जीरो हो सकता है क्या? क्योंकि नॉर्मल फोर्स हमेशा पॉजिटिव रहेगा और फोर्स ऑफ ग्रेविटी एक फिक्स्ड वैल्यू है, तो पॉजिटिव प्लस फिक्स्ड वैल्यू कभी भी जीरो नहीं हो सकता. एट लीस्ट एम जी के इक्वल होगा. सो द centripetal force will at least be equal to mg. So therefore mvc square upon r will be greater than or equal to mg. तो वेलोसिटी सबसे कम तब होगा जब नॉर्मल फोर्स जीरो होगा C पर, and only the gravitational force will be responsible for the centripetal force. Okay. इसका मतलब for the minimum velocity we will have Vc is equal to square root of gr. So what will be the value of Va? So Va should at least be square root of 5 gr. Only then the body will be able to complete a full circle, full vertical circle. If the velocity at A is less than 5 gr, then what will happen is before completing a full circle, the ball will come down. So like कैसे होगा? अगर वेलोसिटी स्क्वायर रूट ऑफ 5 gr से कम है तो ये बॉल ऐसे जाएगा और यहीं से वापस आ जाएगा, बिकॉज बीच रास्ते में ही सेंट्रीपिटल फोर्स उसको मिलेगा नहीं. बट अगर स्क्वायर रूट ऑफ 5 gr होगा तो यहाँ से यहाँ जाएगा, पूरा ऊपर तक होते हुए वापस आएगा. एंड अगर स्क्वायर रूट ऑफ 5 gr से भी ज्यादा वेलोसिटी है तो क्या होगा? उस केस में सी पॉइंट पर नॉर्मल फोर्स जीरो नहीं होगा, नॉर्मल फोर्स पॉजिटिव होगा, जिससे बॉल को वापस नीचे की तरफ लाएगा. तो अगर स्पीड ज्यादा होगा तो भी वो फुल सर्कल ही काटेगा, बट स्पीड बढ़ जाएगी हर पॉइंट पे. इसलिए व्हाट वी हैव कैलकुलेटेड स्क्वायर रूट ऑफ 5 gr इज ओनली द मिनिमम वेलोसिटी. वेलोसिटी उससे ज्यादा हो सकता है बट उससे कम नहीं हो सकता. So what we have seen is that for a vertical circle of radius r, minimum velocity at A is square root of 5 gr, and for this value the velocity at the top point C will be square root of gr. Okay, what will be the velocity at points B and D? कंजर्वेशन ऑफ मैकेनिकल एनर्जी यूज करो. टोटल एनर्जी हर पॉइंट पे सेम होनी चाहिए. You should be getting VB is equal to square root of 3 gr. सिमिलरली VD भी आएगा स्क्वायर रूट ऑफ 3 gr. सो सबसे ज़्यादा वेलोसिटी नीचे होगी, सबसे ज़्यादा काइनेटिक एनर्जी नीचे होगी क्योंकि सबसे ज़्यादा पोटेंशियल एनर्जी नीचे है. जैसे जैसे ऊपर जाएंगे वैसे वैसे काइनेटिक एनर्जी कम होगी, पोटेंशियल एनर्जी बढ़ेगी, एंड पॉइंट सी पे पोटेंशियल एनर्जी मैक्सिमम हो जाएगी बट काइनेटिक एनर्जी मिनिमम हो जाएगी. बट at all the points half mv square plus mgh, this will remain a constant. Okay. So if a question comes, what is the minimum speed for a vertical circular motion at the bottommost point? Your answer will be square root of 5 gr. Okay. Let's take the same example. So अगर इसमें वेलोसिटी स्क्वायर रूट ऑफ 5 gr से ज़्यादा होगा तब तो फुल सर्कुलर मोशन करेगा. बट अगर वेलोसिटी स्क्वायर रूट ऑफ 5 gr से कम होगा तब हमने देखा कि ये फुल सर्कल नहीं करेगा, ये बीच में ही कांटेक्ट लीव कर देगा. सो वी हैव टू फाइंड कि एट व्हाट पॉइंट विल इट लीव कांटेक्ट फ्रॉम द सर्कल. सो लेट्स टेक एन एग्जांपल. लेट्स से velocity at the lowermost point is square root of 3 gr. So इस केस में फुल सर्कल करेगा या नहीं करेगा? So at some position it will leave contact with the loop. To find that position we have to calculate the point where the normal force will become zero. यहाँ पर नॉर्मल फोर्स पॉजिटिव होगा पॉइंट ए पर. जैसे जैसे ये ऊपर जाएगा नॉर्मल फोर्स कम होता जाएगा, एंड एक पॉइंट ऐसा आएगा जहां पर नॉर्मल फोर्स जीरो हो जाएगा. जब नॉर्मल फोर्स जीरो हो जाएगा इसका मतलब कांटेक्ट में रहने का कोई पॉइंट नहीं है, बिकॉज नॉर्मल फोर्स तो लग ही नहीं रहा है. तो जब नॉर्मल फोर्स जीरो हो जाएगा उस पॉइंट पर कांटेक्ट लूज हो जाएगा और ये बॉल वापस आ जाएगा. यू हैव टू फाइंड द पोजीशन वेयर द नॉर्मल फोर्स विल बिकम जीरो. ओके, सो क्योंकि अभी टाइम कम है मैं बता देता हूँ ये कैसे करना है, बट क्लास के बाद यू कैन ट्राई ऑन योर ओन. ओके, सो लेट्स से द नॉर्मल फोर्स becomes zero at this position where this angle is theta. So at this point velocity will be in this direction. Let's say the velocity at this point is v naught. Okay. Okay. Now normal force is zero. यहाँ पर मैंने एंगल 90 डिग्री बना दिया इसलिए थोड़ा कंफ्यूजन हो रहा है. थोड़ा सा ऑब्लिक एंगल लेते हैं. So when the body will leave contact, the normal force will become zero and there will be only gravitational force acting in the downward direction. So what will be the component of gravity along the center's direction? ये वाला एंगल होगा 180 माइनस थीटा and gravity का component along the center will be Fg cos of 180 minus theta. So this will be f of g cos theta, which is mg cos theta. So we will say mg cos theta at that point will be equal to mv square upon r. Okay. Because there is no normal force, the entire centripetal force will be provided by the component of gravitational force along the center. So this will be our first equation. The second equation we will get from the conservation of energy. अगर यहाँ पर velocity v है तो यहाँ पर total energy हो जाएगा half mv square plus the potential energy which is mg r 1 plus cos theta. So basically we will find the potential energy at the topmost point. Okay, so ये total height will be this height which is r plus the additional height which is r cosine theta. तक height लेना है हमें. Therefore the potential energy will be mgr 1 plus cos theta. And this will be equal to half mva square because this is the total energy at point A. So we have two equations and using these two equations we can calculate velocity v and angle theta. तो जो भी पूछा है वो निकाल लेंगे. So basically सर्कुलर मोशन में आपको कंजर्वेशन ऑफ एनर्जी लगाना है और सेंट्रीपिटल फोर्स का फॉर्मूला लगाना है. Okay. Now let's come to the banking of roads. Banking of roads क्यों करते हैं हम? What is the need to bank roads? बैंकिंग की जरूरत क्यों पड़ती है? So कभी आप हिल स्टेशन पे जाते होगे तो यू मस्ट हैव सीन दैट जो बाहर वाला एंड होता है रोड का दैट इज अ लिटिल बिट हायर देन द इनर एज. सो उसको हम बोलते हैं बैंकिंग. एंड the main reason of banking is so that we can increase the centripetal force and the car does not slip. Okay, so if we draw the free body diagram of a car on a normal road, there are only two forces acting. One is the gravitational force downwards, the other is the normal force upwards, and then there is the frictional force which is acting in the opposite direction. तो जो भी सेंट्रीपिटल फोर्स है दैट इज बीइंग प्रोवाइडेड बाय द फ्रिक्शनल फोर्स इफ देयर इज नो बैंकिंग. The only force which is acting in the horizontal direction without banking is the frictional force. So F of S, which is equal to mu times F of N, this is equal to mv square upon r. But जब banking हो जाएगा, now let us draw the free body diagram. So now we have a force of normal acting upwards. We have the gravitational force acting downwards. And we have the frictional force acting in the opposite direction. There is only these three forces: the frictional force, normal force, and the gravitational force. Now, apart from the frictional force, you can see there is also a component of normal force along the center. So that means the centripetal force will not only have the component of frictional force, it will also have a component of normal force. Therefore, the centripetal force will be more, and we would get a better circular motion if there is banking. Okay. Okay. So let us draw the forces. One is the normal force F of n. Then there is the gravitational force mg, and the net force acting along the center will be Fn of sine theta, and this will be equal to mv square upon r. So using this formula you can calculate the velocity और द रेडियस, और जो भी पूछा है क्वेश्चन में वो आप निकाल सकते हैं. ओके, सो अगर हम इस डायग्राम में देखें तो ये गाड़ी ऐसे सर्कुलर मोशन पे जा रही है. 3D में आप इमेजिन करो तो ये अंदर की तरफ जा रही है गाड़ी. तो सेंटर की तरफ जो कंपोनेंट होगा वो ये वाला कंपोनेंट होगा, विच इज Fn sin थीटा. एंड अगर फ्रिक्शन भी होगा तो डिपेंडिंग ऑन द डायरेक्शन यू कैन ऐड और सब्ट्रैक्ट फ्रिक्शन. ओके, सो इसका एक कर्व्ड बैंकिंग का एक फॉर्मूला होता है, वी स्क्वायर अपॉन आर जी इज इक्वल टू म्यू प्लस माइनस टैन थीटा अपॉन 1 माइनस प्लस म्यू टैन थीटा. इसका एक बार डेरिवेशन आप पेपर पर लिखकर देना. नॉर्मल फोर्स और फ्रिक्शनल फोर्स का कंपोनेंट लेना है एंड उसको वी स्क्वायर बाय आर के इक्वल करना है. सो दिस इज द फॉर्मूला फॉर बैंकिंग ऑफ रोड्स. तो अगर आप इसको ध्यान से देखो तो अगर ये जी को हम इधर ले जाएं तो ये वी स्क्वायर अपॉन आर बन जाता है, जो कि एम से अगर मल्टीप्लाई कर दें तो ये हमारा सेंट्रीपिटल फोर्स बन जाता है. ओके ओके, एंड द नेक्स्ट टॉपिक इज द टेंशन फोर्स. सो इसमें एक सिंपल पेंडुलम का केस आता है. अगर हम सिर्फ 2 डायमेंशंस में पेंडुलम को देखें तो एट द बॉटम मोस्ट पोजिशन देर आर 2 forces. One is the gravitational force, the other is the normal force. Okay, वेलोसिटी इस वाली पोजीशन पर 0 होगी या नॉन जीरो होगी? सो इस पॉइंट पर या तो राइट या तो लेफ्ट की तरफ एक वेलोसिटी होगी. सो व्हाट विल बी द सेंट्रीपिटल फोर्स एट दिस पोजीशन? So Fn minus Fg will be equal to mv square upon r. और ये नॉर्मल फोर्स नहीं होगा, ये टेंशन फोर्स होगा क्योंकि स्ट्रिंग अटैच्ड है. So what will be the tension force at the bottom of the pendulum? It will be mg plus mv square upon r. एंड अब हम एक्सट्रीम वाले पोजीशन को देखते हैं. लेट अस से दिस एंगल इज थीटा. So at this position there are 2 forces again. One is the gravitational force and the other is the tension force acting at some angle. So what will be the centripetal force in this case? Okay, so centripetal force will be Ft minus Fg cos theta, and will it be equal to 0? Okay, so at the extreme position velocity is 0, तो यहाँ हम कह सकते हैं this will be equal to 0. So at position number C, at position C, the tension force will just be equal to mg cos theta. But at position A, which is the bottommost point, the tension force will be equal to mg plus mv square upon r. सो कई बार ये क्वेश्चन आता है और mv स्क्वायर अपॉन r वाला टर्म लगाना भूल जाते हैं बच्चे, तो सिर्फ mg मार्क करके आ जाते हैं. ओके, सो यू हैव टू बी केयरफुल. ये भी सर्कुलर मोशन है तो इस पे भी सेंट्रीपिटल फोर्स आएगा. देन इस पॉइंट पर वापस फोर्स ऑफ टेंशन हो जाएगा mg cos थीटा. ओके, so if a question comes, at which point is the tension of a simple pendulum maximum, what will be the answer? So corner पे तो mg से भी कम होगा because cos theta is less than 1. बट सेंटर पर एक तो mg है ही, उसके ऊपर से एक और टर्म आ रहा है. सो मैक्सिमम टेंशन इज एट द सेंटर. जैसे जैसे राइट या लेफ्ट जाएगा टेंशन फोर्स कम होता जाएगा. देन इसके बाद आता है 3D पेंडुलम. सो अ 3D पेंडुलम is suspended by a thread, but instead of moving left and right, it goes around in a circle like this. And again, the maximum angle is theta. So let us take a point on the path. हम इस point को consider करते हैं point A. So what will be the free body diagram of the bob of the pendulum at point A? mg ऐसे लगेगा और टेंशन ऐसे लगेगा. So what will be the centripetal force? देखो ये है 3D पेंडुलम. सो ये दिस ऐसे ऐसे घूम रहा है. okay? तो इसमें सेंट्रीपिटल फोर्स विल बी अलोंग द सेंटर. बट अलोंग द सेंटर mg का कोई कंपोनेंट है क्या? mg तो नीचे की तरफ लग रहा है. सो व्हाट विल बी द सेंट्रीपिटल फोर्स? okay, centripetal force will just be ft sin theta. सो पिछले वाले केस में क्योंकि 2D मोशन था, सेंटर उसका यहां पर था. okay? इस पॉइंट पर, इसलिए वी हैड टू टेक द कंपोनेंट ऑफ ऑल द फोर्सेस अलोंग द सेंटर. सो इस केस में mg का कंपोनेंट आ रहा था सेंट्रीपिटल फोर्स में, बट यहाँ पर सेंटर इस तरफ हो जाएगा हॉरिजॉन्टल प्लेन में. देयरफॉर mg will not have any component and centripetal force will be ft sin theta, which will be equal to mv square upon r की जगह क्या लिखेंगे? So यहाँ पे you have to be careful that r is not equal to l, r is equal to l sin theta. And now you can solve the equation. So अगर velocity पूछा होगा तो l sin theta को उधर ले जाएंगे. अगर force of tension पूछा होगा तो sin theta को नीचे ले आएंगे. Okay. So here the radius of curvature was the length of the pendulum, but यहाँ पर radius of curvature will be equal to L sin theta. Okay, so that completes all the topics of force